Good afternoon, and then just for the form, I have to reply something to that. I do have it.
Okay.
They're going to see me after class, and then just send me a message. And today we're going to start studying statistics. This will probably be the easiest day because it's just going to be terminology. Starting with why we're studying it. You actually come into contact with it every day. And it's going to help you understand the reports in newspapers, magazines, and journals. And it's also going to help you actually interpret the statistics that you are presented with. A lot of areas actually use it, particularly if you're doing any kind of research, you're using statistics. What is statistics? Well, it's just the science of collecting, organizing, summarizing, and analyzing data to draw conclusions. Right, broadly speaking, there are two types of statistics. The first type is descriptive statistics. And this just summarizes a data set using numbers. Then you have inferential statistics, which is to use those numbers to draw a conclusion. We will also need to use probability in this course. Probability is simply measured of the likelihood of something happening or occurring. Probability is usually misunderstood. We'll discuss that when we actually have to study probability. Variable is just characteristic. So if you want to do a study on hair color would be your variable. Raw score is just an unaltered measurement that you take. As an example, so you have a class, you're given a quiz, it's worth 20 points. The raw score is the number of points that you get out of the 20. If you get a 15 out of 20, your raw score would be 15. A population is the collection of everything that you want to consider. Parameter is a numerical value associated with a population. Let's say we want average value of college or university, like the average cost for students in America. your population would be all college students in America. The parameter would be how much are they spending a year. Then you have a sample, which is a portion of your population. And it's generally not reasonable to survey the entire population. So you pick a subset of that population. We could say MCCC students would be the sample. Statistic is a numerical value associated with the sample. And so the statistic would be the average cost. Why is that there? Okay, that should have come up first, but I'll fix that later. Distribution, just a collection of raw scores. I generally just call it the data set. A random sample is just what it is. It's a sample chosen randomly. When you're choosing a sample, it is important to do so in a way that it is random. This helps you to avoid bias, which can affect your results. Generally speaking, it is impossible to truly get random. One of the most common examples is RNG. You're familiar with RNG, random number generators. That's not actually random. It's pseudo-random because it still follows a seed in an algorithm to find the numbers. Now you can change the seed, which obviously adjusts the algorithm, but it's still following an algorithm. So why would we use a sample set of population? I mentioned one. It's generally just not feasible to do an entire population. How many college students are there in America? Millions. Go ahead. Ask all those millions how much they're paying a year. And then summarize that data. It's going to take a lot of time. It's also going to cost you a lot of money.
In the last one, I didn't get down what sample was. Could you re-explain it?
Sample is just a subset of your population.
Okay.
Right, so you consider the entire population. So again, if we want to just do American adults for something, you would just pick a sample of all American adults, a certain number of them. Population continuously changes. Right, so it's possible by the time you finish your survey, your population has changed, which means now your survey is useless. Well, you can't use the entire population. Now we're talking about variables. Two types. Hair color. It's quality, right? Bless you. Or it's a category, so we call it qualitative data. Generally speaking, non-numbers. But not always. If you look at a survey, 1 to 5, I'm sure you've all seen those types of surveys, like how comfortable do you feel if your team winning, whatever it is, like baseball, so winning the World Series, scale 1 to 5. That is actually qualitative. That would not really be quantitative. Then you have the quantitative, so things like height, weight, salary, those are all numerical. When dealing with quantitative, you have two possibilities. Whole numbers, you can count them, which are called discrete. And then you have your continuous. Height would be considered continuous. There's an infinite number of possibilities. Specifically, it's uncountable as well. Look at 0 to 1, just that interval, 0 to 1. How many values are there between 0 and 1? There's an infinite number of them. Can they be counted? No. Generally speaking, counting means there's a 1-to-1 correspondence between the values and the natural numbers or counting numbers. If instead I asked for the number of fractions, the number of rational numbers between 0 and 1, there's still an infinite number of them, right? But they are actually countable. To prove that, you need a more advanced math course, so do that. I'll save that for like discrete math or something, but the fractions actually are countable. Right, for the most part in statistics, if it's whole numbers, it's going to be discrete. Non-whole numbers will be continuous. That is usually a good rule of thumb for statistics. I'm a math major. Take everything literally. And remember, these are posted online as well, so you don't have to worry about writing down every single word. What are we given here? Survey of 120 students. Found an average of 2.6 hours of TV per day. Yeah, I'm pretty sure this is made up. The department announces students at our college watch about 2.6 hours per day. Classify each Oh, and then classify each of those two sentences as either descriptive or inferential. Start with that one. That is descriptive. Right? They took a sample and they took the average of the hours of TV watched per day. So you're using the 2.6 to describe the sample.
What are some like keywords we can use to find out descriptive? Or
Are you-
phrasing?
It's basically, are you inferring something or are you just describing something?
Okay.
In this case, it's just describing the sample, right? We're not really making any kind of conclusion about the sample.
Okay.
That last one, they're saying, the department is now saying that students at our college watch about 2.6 hours per day. Well, now you're taking that sample and you're inferring something about the population as a whole. Now be inferential. And actually, towards the end of the semester, we would look at that claim and go, yeah, we don't believe you, we test the claim. So example of a raw score in a classroom context, and then describe the corresponding distribution. I actually gave an example already. Quiz scores. Test score. B, a raw score. Let's just use this. So the score you receive out of 20, that would be your raw score. And then describe the distribution. Well, distribution would just be the collection of all the quiz scores, right? Spell. And then from that, we could find the average and find standard deviation. Use that to then test claims if we wanted to. We could actually graph the data, which we'll go over later, look at the shape. Registrar pulls records for 350 randomly chosen students to estimate the mean GPA of all 11,900 students. We want to identify the population in the sample. Population was all the students at that particular college. Right. Your sample would be the 350 that were randomly chosen. Right? Again, notice that those randomly chosen students are a subset of your population. They come from your population. Pollster phoned 600 county residents to estimate the portion of the county that supports a bond measure. What would the population be? As the population?
Would be the votes.
The whole county.
The entire population of the county. Right, so all county residents is your population. Right, so what are you choosing from? That's your population. Right, and then who you choose is your sample. So those 600 county residents would be your sample. Here we want to label each as either parameter or statistic. Mean height of all trees in a national park is 43.7 feet. That's the parameter. Mean height of 75 randomly selected trees is 44.9. That's the statistic. There's a nice way to remember that. Find that slide again. Where was it? Here. Population parameter, both start with a P. Sample, statistic, both start with an S. So consider a population of all current students. We want to determine if the sample chosen is random. First 200 students who enter the gym on a Saturday, would that be random? No. Doesn't go over, but this would be a convenience bias. Computer selects 400 student IDs from the enrollment database. This would be random. At least as random as we're going to ever get. Of course, we are making an assumption about that. And it does say the computer's selecting the 400 student IDs. We're assuming that there was no code input on how to select them. Because you can always adjust the algorithm to pick the ones you want. In which case it would no longer be random. Professor surveys students leaving an evening calculus class. Again, that is not random. This would be a coverage bias. Right, you're only getting data about students taking that particular class. So again, this isn't really covered in the notes, but it is interesting. Because if you're doing your research, you have to take surveys. The wording of a survey can bias your results. So here it says, do you agree that the much needed facilities upgrade should be funded this year? That is definitely what's known as a leading question. In the question, they're implying that this is much needed. People taking the poll probably going to be more likely to say yes, they agree with it. To fix it, you want to make it a neutral question. Right, so you don't want do you agree? Because again, if it says do you agree, most likely going to say just yes, because they don't want any blowback. So you could say instead, what is your opinion on, and we want to leave the upgrade neutral. We don't want to say much needed or not needed. Anything like that where we could possibly bias the results. So you could say, maybe on the proposed facility upgrades or upgrade. And then maybe have it as one of those Likert scales, on a scale of 1 to 5. And you strongly disagree with the upgrades, or you up to strongly agree with the upgrades. That, of course, does present its own problems. The people being asked actually have to know what the proposed upgrades are. We're going to classify each of the following as either qualitative or quantitative. And for quantitative, is it discrete or continuous? Number of sick days taken in a year. That is definitely quantitative. So I'll just write as quant. That is discrete. It's whole days. Generally speaking, I mean, you're not going to take half a sick day. You could argue maybe, yeah, we're going to just keep it simple. Major. Well, this one's really easy. That's definitely qualitative. Body temperature in degrees Fahrenheit.
Qualitative.
This one is quantitative. It's a number, right? What kind of quantitative? This one is continuous. Right, average rest temperature is 98.6. Again, that is also misinterpreted a lot. My rest temperature is 96.8. So for me, a temperature of 99 is a fever. Versus someone who does have a normal rest temperature of 98.6, 99 might be nothing. Me, if I have a 100-degree fever, I'm in trouble. Someone whose rest is 99, 100-degree fever is nothing. You're just slightly elevated. So I do always make sure you're informed when they take my temperature for any kind of measure. I go, my rest is 96.8. I've taken it several times. This way they can better predict. Because if they take temperature 98.6, oh, you're fine. No, that means there's something wrong with me. Which makes it even more amazing I survived my 105 fever. My doctor's like, you should be dead.
Would you get like scarlet fever too? Would you get like scarlet fever? Yeah.
Our roof was leaking and there was black mold in the ceiling.
That's kind of gross.
And I got infected with it and it rose my temperature to 105. It literally felt like I was on fire. That was fun. And to top it all off, it was in my room, so I got kicked out of my house. So I had to rip out the entire ceiling. Oh, that was fun.
Did you do it by yourself?
Oh hell no, I was dying. I'm like, I ain't doing this.
God.
And thankfully it was in a condo, so even though we owned, we weren't responsible for it. The association had to pay for it all. But still got a 105 fever out of it. So now whenever I see a leak, I freak out. I take care of it immediately.
Your immune system's probably crazy now.
Well, now it is because of my two kids. When he first started school, every freaking day I was sick. He was always bringing something home to me. Now my immune system's feel like Superman. Now he comes home and coughs, and I'm just like, whatever. Number of emails received in a day.
That would be quantitative.
That is quant. What kind of quant?
That would be continuous.
Discrete.
Wait,
You can't really receive a fraction of an email. Likert question rating. So again, strongly disagree is a 1, strongly agree is a 5. That is qualitative. Right? The numbers are just there for convenience. Right? Instead of having to constantly write out strongly disagree, neutral, agree, strongly agree, we give them numbers for convenience only, but it's still qualitative. So here we're given a table, and we're going to have several questions. First, list the qualitative variables and the quantitative variables. Let's start with the qualitative. And by the way, this table makes me sad. It's only one mathematician. And there's no physicists. That makes me sad. What are your quantitative? go a step further. Which of those are discrete? Sure. You sure? Couldn't you be 39 years old, 302 days, 5 hours, 3 minutes, and 2 seconds old?
Should we keep it simple?
Technically speaking, they would all be continuous. Realistically speaking, I would agree 8 would be discrete. Because you don't really go that in depth with the age. It's only newborns. And generally speaking, only for what, the first year and a half? Right, you don't generally say, oh, I have a 28-month-old. No, but she's 2. Just stop there. I would argue after 12 months, you just stop. But years teaching is a little more complicated. Because again, do you want to measure full years or do you want to get like per semester? Depends on what you need. But generally speaking, I would agree that's also discrete. Height would be continuous. There would be issues with that as well in terms of measuring error. Like how accurate can you get in the inches? Is it only going to give you exact inches and no fractions? Or is it precise enough to be able to go down to a nano inch, 10 to the minus 9? Because that's going to dictate whether it's discrete or continuous. Oh, okay. That was apparently the next question. Which of the quantitatives are discrete and which are continuous? I already did that. My answer key says that age is continuous. So I'm just going to go with that.
Years teaching?
Years teaching would be the only discrete. The other two are listed as continuous.
How would years teaching be a discrete if you're still teaching?
Right. Generally speaking, when you talk about how long you've been at a job, you don't go by days. It's always measured by how many years have you been there.
Yeah.
So you could still be working there, but you've been there for 8 years.
Okay, so like, it's like,
Right. So I'm entering my 11th year of teaching, which means I've been teaching for 10 years.
so continuous is like a percent and like,
Continuous is just essentially a constant measure.
oh, okay.
Right. So something like height, you can be, for instance, 65.8 inches. But you can go even further than that. You can be like 65.7999993 inches. So that's the difference between discrete and continuous.
Mm. So will like weight be like continuous?
Weight would be continuous. Treating these 5 as a sample, give an example of a statistic. There's only one correct answer. You go, okay, what's the mean age? What's the average age? What proportion of full professors? would be a statistic. The most obvious is mean something, so I'm just going to put down mean age, because we'll study proportions. We'll study all of this. But mean is usually something that everyone should know. What is an average? Okay, look at that, the boring day is over. We got all the terminology out of the way. Question on the basic terminology.
You said before there was it was a synonym for one of the words. I don't remember which one, but can you
Distribution.
Yeah, distribution. What was the?
I call it data set.
Okay.
Distribution generally means something different to me. Or actually study probability distributions. So when I see distribution, I immediately think that, and I don't think that's what this is referring to. It's referring to more of the collection of data.
Okay.
So before you do leave, just make sure you return that agreement form. Also, remember the homework is extra credit. The homework A, section A, will be due by the end of Monday. And that's generally how all the homework's due, just the end of that week. Now there have been some roster changes. So I'm just going to say let's reform groups, because I actually have my index cards today. So we can write them down, and I can get them onto Blackboard for you. And once you form the groups, the rest of the class will be just the worksheet to kind of reinforce what we just did today. So go ahead and reform your groups. Again, have to be size 4 or 5.